This is Checkpoint Quiz 11.8. This is video number 4 and problem number 5. A plane leaves an airport with an airspeed of 350 miles per hour at a bearing of 40 degrees west of north. A 60 mile per hour wind is blowing at a bearing of 10 degrees west of south. We want to find the true speed of the plane and the true bearing, and we want to round approximations to 1 decimal place. The bearing of 40 degrees west of north means that this angle is 40 degrees. This vector is the plane's heading and airspeed. The wind has a bearing of 10 degrees west of south, so the angle down in the fourth quadrant that the wind makes with respect to the y-axis is 10 degrees. When we add vectors together, we add them tail to head, so the vector up here in the second quadrant would also be the wind vector, and completing the parallelogram we would have the vector v. Now in some books you see that the bearing, instead of reporting a bearing like 40 degrees west of north, you would see a bearing reported like this, measuring the angle clockwise from north, and that angle would be 320 degrees. The bearing of a navigation vector is a non-negative angle less than 360 degrees measured in the clockwise direction from due north. The wind bearing of south 10 degrees west, we would report that angle instead as 190 degrees, so a heading of 190 degrees. And the resultant vector goes from the origin across the diagonal. That would be our resultant. And the resultant vector is the plane's course and ground speed. So in other words, the resultant vector is the true bearing and the true speed. Now when we look at the geometry, we have a parallelogram. In a parallelogram, adjacent angles are supplementary to each other. Call the angle alpha drift angle. So that angle is how far the wind is pushing us off course, the drift angle. And the angle theta, we can find each of those quantities. We have a parallelogram, and we know the measure of angle DAB is going to equal 180 degrees minus 50 degrees, because when we look at the angle in the second quadrant that the plane makes with respect to the y-axis is 40 degrees, and the angle in the third quadrant with respect to the y-axis the wind makes is 10 degrees, the measure of angle DAB is 180 minus 40 minus 10, so 180 minus 50, which is 130 degrees. Therefore, theta is angle CDA. That is also equal to 50 degrees because supplementary. They add together to give 180. We know that the vector equation, the resultant vector R, is equal to V plus W. The situation we have is a triangle where we know adjacent sides of a triangle. We know the magnitude of V is 350. We know the magnitude of W, which is 60, and we know the angle in between the two sides, theta, is 50 degrees. We want to apply the law of cosines. The magnitude of R squared is equal to the magnitude of V squared plus the magnitude of W squared minus 2 times the magnitude of V times the magnitude of W times the cosine of the angle between them, which is theta. Here is the equation governed by the law of cosines. Now, putting in the respective quantities, the magnitude of R squared is going to equal 350 squared plus 60 squared minus 2 times 350 times 60 times the cosine of 50 degrees. And when you simplify that on your calculator, you will find that the magnitude of R squared is approximately 99,102.92. And taking the square root, we would find the magnitude of R is approximately 314.8. And remember, that will be in miles per hour, and that is the ground speed of our plane. That's the true speed of the airplane. Now, the drift angle can be found by using the law of sines. And according to the law of sines, we have the sine of alpha divided by the magnitude of W is equal to the sine of theta divided by the magnitude of R. And solving that for the sine of alpha, we get that the sine of alpha is the magnitude of wind vector times the sine of theta divided by the magnitude of the resultant. The sine of alpha is approximately 60 times the sine of 50 degrees divided by 314.8. The sine of alpha is approximately 0.146003. And computing the inverse sine, we find that alpha is approximately 8.4 degrees. So that plane is blown off course by the wind 8.4 degrees. We want to find the bearing of that plane. Well, the bearing is going to equal 40 degrees plus alpha for the total of 48.4 degrees. The bearing is 48.4 degrees west of north.